Good morning, students. Today we can discuss problems on modulus and argument. Now, problem number 18. If given a1 plus ib1 into a2 plus ib2, a3 plus ib3 up to so on an plus ibn equals to a plus ib. Now, require the value a1 square plus b1 square into a2 square plus b2 square up to so on an square plus bn square in terms of capital A and capital B. If suppose z1 and z1 and z2 are two complex numbers, now mod of z1 z2 equals to mod z1 into mod z2 in last class we discussed. Now, here given a1 plus ib1, it is considered z1, it is z2, z3 up to so on zn equals to capital A plus I capital B. Now, take both sides modulus. Now, mod of z1, z2, z3 up to zn equals to mod z1, mod z2, mod z3 so on. Now, that equals to mod of a1 plus ib1, mod of a2 plus ib2 so on, mod of an plus ibn, that equals to mod of an plus a plus ib. Now, modulus of a complex number equals to square root of real part square plus imaginary part square, a1 square plus b1 square into square root of a2 square plus b2 square up to so on square root of an square plus bn square, that equals to square root of capital A square plus capital B square. Now, squaring on both sides, therefore, a1 square plus b1 square into a2 square plus b2 square up to so on into an square plus bn square, that equals to capital A square plus capital B square. Answer capital A square plus capital B square. Now, second option is correct. Next problem, if 1 plus I whole to the power of 100 equals to 2 power 49 of x plus iy, then required the value of x square plus y square. X square plus y square equals to how much? Now, here two complex numbers equal given, take modulus on both sides. Now, that equals to 1 plus I mod whole to the power of 100 equals to 2 power 49 mod of x plus iy. Now, mod of 1 plus I equals to square root of 1 square plus 1 square or 1 plus 1 whole to the power of 100, that equals to 2 power 49 of square root of x square plus y square. Now, root 2 whole to the power of 100 equals to 2 power 50 equals to 2 power 49 into square root of x square plus y square. Now, both sides 2 power 49 cancel, 2 equals to square root of x square plus y square. Now, squaring on both sides, we get x square plus y square equals to 4. The value of x square plus y square equals to 4. Now, second option is correct. Next problem, if LZ2 by mz1 is purely imaginary number, then require the value lambda z1 plus mu z2 by lambda z1 minus mu z2 modulus, require that value. Okay. Here given LZ2 by MZ1 is purely imaginary. Now let it is purely imaginary equals to some IY, because purely imaginary real part equals to 0. Real part equals to 0. Now Z2 by Z1 equals to I my by L. I my by L. Okay. Here required modulus of lambda z1 plus mu z2 by lambda z1 minus mu z2. Now numerator and denominator both divide with z1. We get lambda plus mu z2 by z1 by lambda minus mu z2 by z1. Here numerator and denominator divided by z1, but z2 by z1 equals to I my by L, that equals to mod of lambda plus mu into z2 by z1 I my by L by lambda minus mu I my by L. Now take LCM as L, that equals to lambda L plus I into mu my by lambda L minus I mu my. But here mod of z1 by z2 equals to mod z1 by mod z2, mod z1 by mod z2 in last class to discuss. Now that equals to mod of lambda L minus plus I mu my by mod of lambda L minus I mu my, that equals to square root of numerator real part square lambda L whole square plus mu my whole square by denominator also same thing, square root of lambda L whole square plus mu my whole square. Now numerator denominator same, cancel 1. Answer is 1. Then option D is correct. Option D. Next, 21st problem. The minimum value of mod z plus mod of z minus 1 plus mod of z minus 2. Now consider it is f of z. F of z equals to, here mod z it also can be written as mod of z minus 0. Therefore minimum value of f of z, minimum of f of z equals to minimum of here z minus 0 equals to 0, then z equals to 0, f of 0 or f of here z minus 1 equals to 0, z equals to 1 or f of 1 or similarly f of 2. In these three values which is minimum, that is minimum value of the function f of z. Now first what is f of 0 equals to or minimum of, at place of z equals to 0 substitute 0 plus 0 minus 1 means mod minus 1, that equals to 1. Here z equals to 0 substitute mod of minus 2 equals to 2, 1 plus 2 3. Next f of 1, z equals to 1 substitute, it is 1, it is 0, minus 1 mod, that equals to 1 plus 1 2. Next f of 2, 2 here z equals to 2, substitute 2, 2 minus 1 1, 2 plus 1 3, it is 0 3. Now in this which is minimum, that is minimum value of f of z. Therefore, minimum value of f of z f of z is, in these three minimum is 2, answer 2. Now in given option, third option is correct. Next problem, if mod of z plus 2i is less than or equals to 2, then greatest value or maximum value of mod of z minus root 3 plus I required. The maximum value or greatest value of mod of z minus root 3 plus I. Now it can be written as mod of z plus 2i minus 2i, add and subtract 2i. Next remaining terms minus root 3 plus I. Now that equals to mod of z plus 2i, next to minus 2i plus I minus root 3, or minus of root 3 plus I. Now if suppose z1 and z2 are two complex numbers, then mod of z1 minus z2, it is always less than or equals to mod z1 plus mod z2. In last class we discussed. Now it is considered z1, it is considered as z2, it is z1 z2. Now it is less than or equals to mod of z plus 2i plus mod of root 3 plus I. But this value given in problem 2, it is less than or equals to 2 plus modulus of root 3 plus I, that equals to square root of root 3 whole square plus 1 square. It is less than or equals to 2 plus root 3 whole square, 3 plus 1 4, square root of 4 is 2, or it is less than or equals to 4. Therefore, maximum value is 4, because its value less than or equals to, then maximum value is 4. Then fourth option is correct. Next problem, if mod of z minus 4 by z equals to 2, then maximum value of mod z, required maximum value of mod z. Now mod z, it can be written as mod of z minus 4 by z plus 4 by z, add and subtract 4 by z. Okay. Now it is considered z1, it is z2. Always mod of z1 plus z2 less than or equals to mod z1 plus mod z2, that equals to mod of z minus 4 by z plus mod of 4 by z, mod of 4 by z. Now mod z equals to or less than or equals to, here this value given z minus 4 by z equals to 2 plus 4 by mod z, 4 by mod z. Now take LCM as mod z and cross multiply, we get mod z whole square less than or equals to 2 mod z plus 4. Now mod z square, this 2 mod z take left side, minus 2 mod z less than or equals to 4, less than or equals to 4. Add 1 on both sides, mod z whole square minus 2 mod z plus 1 equals to 4 plus 1. Adding 1 on both sides, add 1 on both sides. Now left side it is mod of z minus 1 whole square, mod z minus 1 whole square, a square minus 2ab plus b square form. It is less than or equals to 5, 4 plus 1 5, for implies mod z minus 1 is less than or equals to root 5. One take right side, therefore mod z less than or equals to 1 plus root 5. Now here maximum value is 1 plus root 5 or root 5 plus 1. Second option, option B is correct. Next problem. If mod of z1 minus 1 less than 2, mod of z2 minus 2 less than 1, then required mod of z1 plus z2, given options. Now mod of z1 plus z2 required, it can be written as mod of z1 minus 1 plus z2 minus 2 plus 3, means add and subtract 3, add and subtract 3. Now it is consider it is z1, z2, z3, it always less than or equals to mod of z1 minus 1 plus mod of z2 minus 2 plus mod 3. It is less than or equals to only less than, okay, because here only less than given values, less than it is 2, this value is given only 2 plus mod of z2 minus 2 less than 1 plus 3, it is less than 2 plus 1 plus 3, 6, it is less than 6. Now option D is correct. Next problem. z1, z2 are two non-zero complex numbers such that mod of z1 plus z2 equals to mod z1 plus mod z2. Then argument of z1 minus argument of z2, argument of z1 minus argument of z2 required. Okay. Now first let z1 equals to x1 plus iy1, z2 equals to x2 plus iy2, x2 plus iy2. Now z1 plus z2, add these two, how much we get? Mod of x1 plus x2, x1 plus x2. In next two terms, in iy1 and iy2, I take common I of y1 plus y2 equals to mod of x1 plus iy1 plus mod of x2 plus iy2. Now magnitude, its modulus or absolute value equals to square root of x1 plus x2 whole square plus y1 plus y2 whole square, that equals to square root of x1 square plus y1 square plus square root of x2 square plus y2 square. Now squaring on both sides, squaring on both sides, we get x1 plus x2 whole square, square and root cancel, expand this one, x1 square plus x2 square plus 2x1 x2 plus y1 square plus y2 square plus 2y1 y2 equals to x1 square plus y1 square plus x2 square plus y2 square plus 2ab term, 2 square root of x1 square plus y1 square into square root of x2 square plus y2 square we get. Now x1 square cancel, y1 square cancel, x2 square and y2 square also cancel on both sides. Now the remaining value 2 of x1 x2 plus y1 y2 equals to 2 into square root of x1 square plus y1 square into x2 square plus y2 square. Now 2 also cancel, again squaring on both sides, we get left side a plus b whole square formula, x1 x2 whole square plus y1 y2 whole square plus 2 x1 x2 y1 y2 equals to, now square and root cancel, after that multiply the two factors, we get x1 square x2 square, x1 square x2 square plus x1 square y2 square plus y1 square x2 square plus y1 square y2 square. Now y1 square y2 square cancel, x1 square x2 square also cancel. Now complete terms take right side, we get x1 square y2 square plus y1 square x2 square minus 2x1 y2 x2 y1 equals to 0. Here x1 x2 y1 y2, x1 x2 y1 y2. Now left side value x1 y2 minus x2 y1 whole square equals to 0. Now therefore x1 y2 minus x2 y1 equals to 0. Now x1 y2 equals to x2 y1, or for implies y2 by x2 equals to y1 by x1, y2 by x2 equals to y1 by x1. Now both sides take tan inverse of y2 by x2 equals to tan inverse of y1 by x1, y1 by x1. But tan inverse of y2 by x2, it is nothing but argument of z2 equals to argument of z1. Now argument of z1 minus argument of z2 equals to 0. Now first option is correct. Next problem, the principal amplitude or argument, amplitude and argument are same, of 2 minus I into 1 minus 2I whole square. Now first to simplify this one or convert in the form of x plus iy, x plus iy. Now 2 minus I into a minus b whole square, 1 plus 4I square minus 4I, that equals to 2 minus I into I square equals to minus 1, 4I square equals to minus 4, 1 minus 4 minus 3 minus 4I. Again multiply these two factors, minus 6 minus 8I plus 3I minus of minus plus 4I square, that equals to, here I square equals to minus 1. Now minus 4 minus 6 minus 10 minus 5I minus 5I. Now it is in the form of x plus iy, x plus iy. Now argument, it is considered z, z equals x plus iy. Argument of z equals to tan inverse y by x, that equals to tan inverse minus 5 by minus 10, that equals to tan inverse 1 by 2. But the point here x equals to minus 10, x equals to minus 10, y equals to minus 5. Now minus 10 comma minus 5. This point belongs to third quadrant Q3, third quadrant. Now amplitude lies in the third quadrant, third quadrant. Now option is, it lies in the minus pi to minus pi by 2. Third option is correct. Third option correct. Next, if mod z1 equals to mod z2 and argument of z1 plus argument of z2 equals to pi by 2. Now argument of z1 plus argument of z2 equals to pi by 2 given, pi by 2. But argument of z1 plus argument of z2 equals to argument of z1 z2. Argument of z1 z2 equals to pi by 2, pi by 2. Now argument of z2 pi by 2, if suppose x axis or imaginary axis, real axis, imaginary axis, argument is 90 degrees. Therefore z1 z2 lies on the imaginary axis, lie on the imaginary axis. Any point lie on the imaginary axis, real part equals to 0. Real part 0 means it is purely imaginary. Therefore z1 z2 is imaginary or purely imaginary. Second option. Next, if pi by 3 and pi by 4 are arguments of z1 and I think it is z2 bar. Now then the value of argument of z1 z2. Now given argument of z1 equals to pi by 3 and argument of z2 bar equals to pi by 4. Now for in place argument of z2 equals to minus pi by 4, minus pi by 4. Now required argument of z1 z2, that equals to argument of z1 plus argument of z2. Now that equals to pi by 3 minus pi by 4. Take LCM as 12, that equals to numerator pi, 4 pi minus 3 pi pi. Now answer is pi by 12. Option is B. Next, the mod amplitude form of 1 plus cos theta plus I sin theta is. Now mod amplitude form of the complex number or mod argument form r into cos theta plus I sin theta, or it is also written as r into cis theta. Here cis theta nothing but cos theta plus I sin theta, means this equation convert in the form of r into cis theta. Now here 1 plus cos theta equals to 2 cos square theta by 2, half angle form, plus I into sin theta equals to 2 sin theta by 2 cos theta by 2. Now 2 cos theta by 2 take common, 2 cos theta by 2 common. Now cos theta by 2 plus I sin theta by 2. Now that equals to 2 cos theta by 2 into cos theta by 2 plus I sin theta by 2, nothing but cis theta by 2. Now option is second option. Next, if pi by 2 less than alpha less than 3 pi by 2, means alpha lies in the second quadrant or third quadrant, then the modulus argument form of 1 plus cos 2 alpha plus I sin 2 alpha. I sin 2 alpha. Now 1 plus cos 2 alpha equals to 2 cos square alpha plus I into sin 2 alpha equals to 2 sin alpha cos alpha. 2 sin alpha cos alpha. Now 2 cos alpha take common, we get cos alpha plus I sin alpha. Cos alpha plus I sin alpha. But here given alpha lie in the second and third quadrants. Therefore, alpha equals to two cos of alpha minus pi into cos alpha minus pi plus I sin alpha minus pi, that equals to cos 180 minus theta equals to minus cos theta, minus 2 cos alpha into cos alpha minus pi plus I sin alpha minus pi is the answer. Now option is first option. Next, the mod amplitude form of 1 minus I root 2. Now mod amplitude form of the complex number equals to R into cis theta, where theta equals to tan inverse y by x, that equals to tan inverse minus root 2. Theta equals to tan inverse minus root 2. Now R equals to mod of the complex number square root of 1 square plus minus root 2 whole square, that equals to root 3. Therefore, mod amplitude form equals to R into cis theta, but R equals to root 3. Root 3 into cis tan inverse minus root 2, because the theta equals to tan inverse minus root 2. Now it is the answer. Now third option, option C is correct. Next, 32, log of log I equals to. Now first of all, if suppose cos alpha plus I sin alpha equals to e power I alpha. Now Euler's formula, cos alpha plus I sin alpha equals to e power I alpha. Now first I equals to, I can be written as 0 plus I into 1. Now it convert in the form of cos alpha plus I sin alpha. Cos alpha equals to 0, then alpha equals to 90. Now cos pi by 2 plus I sin pi by 2, sin 91, that equals to, it is nothing but e power I pi by 2. I equals to e power I pi by 2. Now required log of log I. Log I equals to e power I pi by 2. That equals to log of I pi by 2 log e base e. Without base means always with base e, but log e base e equals to 1, that equals to log I pi by 2. Now log m into log n, log m into n, that equals to log I plus log pi by 2, log I plus log pi by 2. Again here log I equals to, log I value equals to I pi by 2, log I equals to I pi by 2 plus log pi by 2. The answer is I pi by 2 plus log pi by 2. Third option, log pi by 2 plus I pi by 2. Next, tan of I log A minus IB by A plus IB, tan of log A minus IB by A plus IB, require this value. Now it also can be written as, because log 1 by x equals to minus log x, log 1 by x equals to minus log x. Now it is reciprocal it, that equals to tan of minus I log A plus B, A plus IB by A minus IB, A plus IB by A minus IB, these two reciprocal, because log 1 by x equals to minus log x, here minus sign we get. Now first to find out log of, first A plus IB by A minus IB, A plus IB by A minus IB equals to, now numerator and denominator both divide with, or just a minute, now it is equals to A plus IB by A minus IB into A plus IB by A minus IB, A plus IB multiplied and divided by A plus IB. Now that equals to numerator A plus IB whole square by A square plus B square, or it also can be written as A plus IB by root of A square plus B square whole square, root of A square plus B square, because in denominator put square root and square. Now it also can be written as A by square root of A square plus B square plus I into B by square root of A square plus B square whole square, whole square. Now here let cos alpha equals to A by square root of A square plus B square, and this one for implies we get sin alpha equals to B by square root of A square plus B square, and tan alpha equals to sin alpha by cos alpha, that equals to B by A, sin alpha by cos alpha, tan alpha equals to B by A. Now this value equals to cos alpha plus I sin alpha whole square. Now therefore A plus IB by A minus IB equals to cos alpha plus I sin alpha whole square, where cos alpha equals to A by square root of A square plus B square and sin alpha equals to B by square root of A square plus B square, or it is also cos alpha plus I sin alpha equals to e power I alpha whole square, that equals to e power 2I alpha, 2 alpha I. Now A plus IB by A minus IB equals to e power 2I alpha, here A plus IB by, now take this value or it is considered C. Therefore, C equals to tan of minus I log e to the power of I to alpha log x power n equals to n log x tan of minus I into I to alpha. Now, I into I square equals to minus 1, that equals to tan 2 alpha. Require the value of tan 2 alpha. Therefore, tan 2 alpha equals to 2 tan alpha by 1 minus tan square alpha. But tan alpha equals to b by a. 2 into b by a by 1 minus b square by a square. Now take LCM and simplify. We get 2ab by a square minus b square. Now answer is 2ab by a square minus b square. Second option is correct. Second option. Next, log of 1 plus I root 3 by 1 minus I root 3 equals to, given options I pi by 3, I 2 pi by 3, so on. Okay. Now, log of, here numerator and denominator divide with 2, 1 by 2 plus root 3 by 2 I by 1 by 2 minus I root 3 by 2, that equals to log of 1 by 2 equals to cos pi by 3, cos 60 degrees value, plus I into sin pi by 3 by denominator also same cos pi by 3 minus I sin pi by 3, that equals to log of cos alpha plus I sin alpha e power I alpha. Now e power I pi by 3 by denominator e power minus I pi by 3, that equals to log of e to the power of I 2 pi by 3. Now log x power n equals to n log x, that equals to I 2 pi by 3 log e base e, but log e base e value 1, that equals to I into 2 pi by 3 with the answer I into 2 pi by 3. Now second option, option B is correct. Next, 35. The points 9 plus 4, 9 plus I, 9 plus I, comma 4 plus 39, minus 8 plus 8I, minus 3 minus 4I. In the organ diagram represents rhombus, square, rectangle, parallelogram. First point A, 9 comma 1. Real part is 9, imaginary part 1. Second point consider B, 4 comma 13. Third point C, minus 8 comma 8. Fourth point D, minus 3 comma minus 4. Minus 3 comma minus 4. Now, if suppose ABCD is a square, ABCD is a square, then compulsory here what are the conditions? AB and BC, CD all are equal, means AB equals to BC and AB square plus BC square equals to CA square, because ABC is a right angle triangle, Pythagoras theorem. If suppose ABCD is a rectangle, ABCD rectangle, then in that case AB not equals to BC and AB square plus BC square equals to CA square, then rectangle. Next to rhombus ABCD is a rhombus, then sides equal AB equals to BC and AB square plus BC square not equals to CA square, not right angle property. If suppose it is a parallelogram, in that case AB not equals to ABCD is a parallelogram, AB not equals to BC and AB square plus BC square is not equals to CA square. Right angled property also not satisfied. Now first to find out AB, BC and CA. Now AB equals to distance between 2 points square root of 9 minus 4 whole square plus 1 minus 13 whole square, that equals to root of 25 plus 144, root 169 or 13. AB equals to 13. Next to find out BC. BC equals to square root of distance between B and C, 4 plus 8 whole square plus 13 minus 8 whole square, that equals to root of 144 plus 25 equals to 13. Next to AC equals to distance between these 2 points A and C, square root of 9 plus 8 whole square plus 1 minus 8 whole square, that equals to 9 plus 8, 17 square, 289 plus 7 square, 49, that equals to root of 8, 338. Now what is here? AB equals to BC. AB equals to 13, BC is also 13. Next to what is AB square plus BC square equals to 169 plus 169, that equals to 338. It is equals to AC square. Right angled property also satisfied. Therefore, it is a square. Answer B. It is a square. Next, 36. Here let A equals to 2 by root 3 e to the power of minus I pi by 6. B equals to 2 by root 3 e to the power of I pi by 2. C equals to 2 by root 3 e to the power of minus 5 pi by 6 are 3 points forming a triangle ABC in Gaussian plane or organ plane. Then the triangle ABC is equilateral, isosceles, scalar and right angled. Now first A equals to given A equals to 2 by root 3 e to the power of I alpha equals to cos alpha plus I sin alpha, cos minus pi by 6 plus I sin minus pi by 6. Now that equals to 2 by root 3 into cos minus pi by 6 root 3 by 2 minus I into 1 by 2. Multiply it, 2 first to take common and cancel it, that equals to 1 minus I into 1 by root 3. Therefore, the point A A equals to 1 comma minus 1 by root 3, 1 comma minus 1 by root 3. Similarly, the point B equals to 2 by root 3 e power I pi by 2, that equals to 2 by root 3 into cos pi by 2 plus I sin pi by 2. Cos 90 value 0, sin 90 1, that equals to 2 by root 3 into 0 plus I, that equals to 2I by root 3. Therefore, the point B equals to real part 0, imaginary part 2 by root 3. Next, point C, 2 by root 3 e power minus I 5 pi by 6, that equals to 2 by root 3 into cos minus 5 pi by 6 plus I sin minus 5 pi by 6, that equals to 2 by root 3 into cos minus 5 by 6 equals to minus root 3 by 2, sin minus 5 pi by 6 minus I into 1 by 2, or that equals to, we get 2 common and cancel it, multiply it 1 by root 3 minus 1 minus I into 1 by root 3. Now, the point C minus 1 comma minus 1 by root 3. Now, next to find out the lengths of the sides of the triangle. After that, decide what type of the triangle. Now, AB equals to distance between 2 points equals to square root of 1 plus 3 root 3 by 3, root 3 whole square 3, that equals to 2. Next, to BC equals to distance between 2 points. It is also 1 minus of minus plus 3, 2. Next, to AC equals to root of 1 plus 1 whole square means 4 plus 0, that equals to also 2. Now, all the 3 sides AB, BC and CA 3 are equal, therefore, triangle is equilateral triangle. Next, 37. The area of the triangle whose vertex is 0, Z, e power I alpha. Now, first point is 0 comma 0, second point Z. If suppose consider x comma y, means Z equals to let x plus iy, therefore point x comma y. Next to Z into e power I alpha equals to x plus iy into so on. Otherwise, see it here, origin, first point is origin, it is considered Z, this point is Z, Z into e power I alpha, e power I alpha. Therefore, length of this side or distance between these 2 points equals to mod Z. Distance also magnitude is Z, mod Z. Next to angle between these two, alpha, they are given alpha, angle between these two sides is alpha. Now, area of the triangle, ABC equals to half into product of two adjacent sides, means mod Z into mod Z into sine of angle between the two sides, sin alpha, or that equals to half into mod z square sin alpha, half into mod z square sin alpha. Second option. Next 38. The area of the triangle formed by z, omega z, z plus omega z is 4 by root 3, 4 by root 3, where omega is complex cube root of unity, then mod z equals to. Now, here the area of the triangle formed by these values equals to root 3 by 4 mod z square, but that equals to given 4 by root 3. Mod z square equals to 4 by root 3 whole square, or implies mod z equals to 4 by root 3. Mod z equals to 4 by root 3. Option D. Next 39. The complex number such that mod of z minus 1 equals to mod of z plus 1 equals to mod of z minus I. The number of complex numbers of z such that. Now, it is nothing but distance between z and 1 comma 0. Here distance between minus 1 comma 0 and 0 comma 1. Now, observe it. These 3 points lie on a circle, x square plus y square equals to 1. Now, if suppose z is 0, radius of the circle is 1 unit. Now, the 3 points lie on the circle, therefore, circumcenter is origin, means z is origin, means only one solution, number of solutions are 1, because only one point is equidistant from 3 vertices of the triangle, that is nothing but circumcenter of the triangle. Okay, thank you very much. Tomorrow continue the same problems.